Oh, look, my face paused. Oh, there it goes. Now we're back. Hello and welcome to Conceptual Physics. My name is Mr. Sportel, and I will be your teacher. You have hopefully just completed the 8.2 Distance and Graphs document. And now I'm going to guide you through the wonderful answers that you so desire. Hopefully, you have got all of them right. But if not, don't fear. There's explanations too. Now, let's walk through this. Start with the first one. You walk 4 meters away from the origin. Then you walk 3 meters towards the origin. Then you walk 2 meters away. How far are you? 3 meters away. Total, you went 9 meters. Okay, that's the whole displacement versus distance thing that you wrote about in the original 8.1. And then you put your answers on Moodle, didn't you? Anyway, sorry, apologies. Let's suppose you are starting at 1 meter away from the detector. Then you walk at a slow and steady rate for 4 seconds. Notice how 4 seconds passes. This wonderful line right here is depicting an even, slow pace. You're going about half of a meter every 2 seconds. So this one goes from 1.5. This one goes from 1.5 to 2. So you're going half a meter every 2 seconds. Then you stop. Stand still. Remember, the flatter the line is, the slower you're going. Because when it's perfectly flat, horizontal like this, your position is not changing, which means you are standing still. Now, this one I'm going towards the detector quickly, which means I have to be moving towards the origin, towards this 0. But I'm going quickly. So this slope is going to be slopier. It's going to have more change per second. So notice how this one only went up half a meter every 2 seconds. This one is going from 2 meters to 0 meters in 2 seconds. So that's roughly 4 times faster. Pretty quick. Okay? Okay. That's the part where you respond and I don't hear you. Alright, let's move this a little bit. Number 2. Number 1? Get out of there. What do you do to create a horizontal line? You stand still. That's what you do. So stand still. Position doesn't change over time. Number 3. How do you walk to create a straight line that slopes up? Remember, sloping up means the position is increasing, and that means you're moving away. So I'm moving at a constant speed away from the detector. Then, how do you walk to make a straight line that slopes down? You walk towards the detector at a constant rate. Notice how the slope, the rise over run, remains constant, which means my change in position remains constant over the same chunks of time. It's like saying I'm going 3 meters every 1 second or 8 meters every 5 seconds. Just consistently going those same rates will give you those nice straight lines. Next, number 5. You're going to walk away and then you're going to slow down. So let's imagine I'm running away and get very tired because I'm not in shape, and then I slow down and jog slower because I realize I can't keep up that pace. Or if I'm being chased by a bear, real realistic story, and then I slow down because I think I got away from the bear, and then my graph ends because the bear was actually hiding from me and he attacked me and I was done. Sorry, apologies. It's a fairly sad ending to that story. What we're going to do is just make sure we point out these 2 lines are very differently sloped, but they're both pointing up. That's the key here. The position is increasing on both of them because they're both moving away. That's the important piece I want you to take away. You can have 2 lines both moving away, and both of them can have different slopes, which means this one's faster, this one's a little bit slower. The closer you are to horizontal, the slower you're going. Now, how to create a U-shaped graph? Go like this. U. And then you just make it look really big. U. No, that's not actually the answer. What you need to figure out is how do you make a graph that looks like this? So what would you have to do? What would you have to walk, or what motion do you have to produce in order to make a graph that looks like this? Okay? That is where you aren't getting the answer right now, because you're going to have to put your answer on Moodle. So I'm not going to give that answer to you. You're going to have to figure it out from the clues that are hidden throughout this entire document and from your wonderful brains that you have in your heads. So, without further ado, let's move on to the next page. The object moves at a steady constant velocity way. Constant velocity, moving away, so position's going up. Standing still, once again, flat line, position's not changing. Number 9 gets a little trickier. Now it's moving at a steady rate towards the origin, 5 seconds. Notice how we have the 5 seconds marked. And then flat line, because we're standing still again. This one, notice how the slopes are just the opposite. One's going up, one's going down. And so what we find is that they're going the same speed, just different directions. This one's going away from the origin, and then this one's going back towards the origin. But their slopes, rise over run. Notice how similar those are. Then right here, the object moves away from the origin, starts slow, and then speeds up. Starts slow, it doesn't change a lot in position over this amount of time, and then it speeds up, gets faster and faster and faster and faster as we go. The more up and down it is, the faster you're going, because you're changing more of your position over a short amount of time. If I were to ask, I want you to draw me a graph of something that's moving towards the origin and speeding up, for instance. So we know it's speeding up, so it's getting faster. So this will be our beginning. We'll kind of flat, and then we'll speed up and go down, because we're moving towards the origin, this 0 line. So we would go, that would be moving towards the origin and speeding up, whereas this is moving away from the origin and speeding up. Alright, that is the end of the document. If you have questions about any of this, make sure you put your questions onto that wonderful Google Doc that we all share and live in together. If you've got ideas for better ways to communicate, please let me know. I'd love to do some live video chat kind of stuff with you, just to try and help answer some of these questions. If we have a bunch of questions, I'll gladly try and set that up for us. But watch the video again if you need to. Otherwise, I think you're going to do great. You're great. You're smart. You can handle this. Just make sure you ask for help when you need it. All right. Until further adieu. I bid you adieu. What is that, French? I don't remember.